By 1979, several mobile radio networks already existed worldwide. They operated on different frequency bands and were based on different standards. A mobile phone user in Britain could not use his mobile phone in Sweden, because the British and the Swedish mobile radio networks were each based on their own standards, with different signaling protocols, and were incompatible with each other. In view of the European unification process, it became clear that mobile telephony too had to overcome national borders. A new European standard was due. For this purpose, the Conférence Européenne des Administrations des Postes et des Télécommunications established a work group, whose task was to work out specifications for a standard Western European mobile system. This was the Groupe Spécial Mobile, GSM, after which the new standard, the Global System for Mobile Communications, was named. In 1988, the European Telecommunication Standards Institute, ETSI, was founded. Its task was to work out the GSM standard for a digital radio telephone network. In the GSM 900 standard, the frequency range between 890 and 915 MHz was assigned to the uplink, and the range between 935 and 960 MHz was assigned to the downlink. In GSM 1800, the frequency ranges 1710 to 1785 MHz were added in the uplink, and 1805 to 1880 MHz in the downlink. In 1995, GSM 1900, with its own frequency range from 1850 to 1910 MHz in the uplink, and 1930 to 1990 MHz in the downlink, was implemented in America. At the end of 1996, there were already 120 GSM networks in operation, and within the year 2000, there were already 150 million GSM users all over the world. The GSM specification had to consider the following. The system had to function Europe-wide, provide a high speech quality, use the available frequencies as efficiently as possible, provide ISDN service characteristics, be compatible with other ways of data transmission, and meet high security requirements as far as the customers and the transmitted information were concerned. Many of these conditions have been turned into advantages for the users of today. The available frequencies are used efficiently. The average speech quality is higher than in analog mobile networks. Speech encryption guarantees the security standards. A wider range of services provided compared to analog cell networks, like voice, fax, data or internet services. International roaming between all GSM countries is possible. Furthermore, international competition reduces the prices. Today, GSM is the first digital cellular mobile communication system to enable international roaming and ISDN service characteristics. GSM is an open standard for services, infrastructure and communication, independent of the individual countries, network operators and producers, and flexible to the requirements of the individual user. All this has boosted the development of GSM. Now, over 300 network operators in 130 countries are offering GSM services. Over 150 million customers use GSM. And a considerable share of the worldwide telecommunication market goes to GSM products and services. The cellular structure in GSM provides an almost complete radio coverage. The system allows a maximum distance of 35 kilometers between the mobile station and the base station. Therefore, the geographical area where GSM is used must be subdivided into smaller areas, which are known as cells. The cell size must be adjusted to the subscriber density and to the environment. If a subscriber moves from one cell to another during a call, the connection is handed over from the old radio station to the new radio station without any interruptions. This procedure is called handover. GSM distinguishes different channels on the basis of their frequency. Each cell is assigned one or more frequencies, which it uses to serve active subscribers. An uplink-downlink frequency pair can be used by up to 8 mobile stations practically simultaneously. This is done with the help of the Time Division Multiple Access, TDMA. Since there's only a limited amount of available traffic channels, high subscriber numbers require that the frequencies be used several times. This is not an insoluble problem, since several cells can use the same frequency, provided that the distance between the cells is sufficient. But it sometimes makes network planning a very complex task. Thus, GSM offers capacity for more subscribers than one would expect, in view of the very limited supply of frequency resources. To guarantee flexibility, open interfaces are specified in GSM between particular network elements. In this way, network operators can be supplied by different producers. Nevertheless, the interface's functionality is very well specified to guarantee a smooth data transmission. In GSM, there are 2 truly open interfaces. The first one is the air interface, located between the mobile and the base station. The other one is the A interface between the base station subsystem, BSS, and the network subsystem, NSS. The GSM network structure is decentralized and consists of 3 separate subsystems communicating with each other over a series of interfaces. Apart from the network subsystem for routing and subscriber localization, and the base station subsystem, BSS, for radio coverage and radio resource management, there's also the operation and maintenance subsystem, OMS, which guarantees network management and administration. GSM has been designed, above all, for speech communication. Although the standard also offers data services, their possibilities are limited by a data rate of 9.6 kilobits per second. To meet the growing demands of increasingly complex data applications, for example in the multimedia or internet sector, higher data rates are necessary. Therefore, the system's capacity is constantly being enhanced. One extension of the GSM standard is high-speed circuit switch data, HSCSD. This innovation gives the bitrates an enormous boost. HSCSD is circuit switched and optimizes the existing transmission rates in 2 respects. Firstly, a new channel coding method, available in GSM Phase 2 Plus in single circuit switch data, increases the data rate from 9.6 kilobits per second to 14.4. Secondly, the bundling of up to 4 time slots can increase the user data rate to 57.6 kilobits per second. This allows, for example, faster email transfer, faster file transfer, and speedier and thus cheaper web browsing and data download from the internet. As most of the services used require higher data rates in the downlink than in the uplink, HSCSD really shows an asymmetrical implementation. That means 3 time slots in the downlink and 1 in the uplink. This also facilitates mobile station design and avoids battery capacity problems. In contrast to HSCSD, the General Packet Radio Service, GPRS, is packet switched instead of circuit switched. The radio network resources are only used if data is actually being transmitted. Thus, billing is no longer based on the duration of the call, but on the amount of transmitted data. Additionally, the type of data service can be charged, for example web browsing or WAP access. By bundling up to 8 channels, a data rate of up to 171.2 kilobits per second can be achieved, with up to 8 subscribers per channel. The more subscribers transmit data within a cell, the more the data rate available to each individual user is reduced. GPRS requires some modifications to the existing GSM infrastructure. Together with HSCSD, GPRS is a further step towards mobile multimedia. Enhanced Data Rates for Global Evolution, EDGE, is a technology concentrating on the air interface between the mobile and the base station. Based on a new modulation process, 8-phase shift keying, or 8PSK, EDGE achieves 3 times the data rates of HSCSD and GPRS at the air interface. Furthermore, with EDGE, the subscriber can use all 8 time slots at the air interface. In contrast to GSM, a digital data unit at the air interface, a symbol, is not just 1 bit, but 3 bits. This technology allows data rates of almost 474 kilobits per second per user. On the other hand, EDGE is very bit error sensitive and requires careful planning and a sufficient number of base stations. The Universal Mobile Telecommunications System, UMTS, represents the 3rd generation of mobile communication. It achieves bit rates of up to 2 megabits per second, if the mobile is static and no other user is transferring any data. Realistic situations will allow a maximum of 144 or 384 kilobits per second. The introduction of UMTS won't make GSM unnecessary. Simple services like speech will be dealt with by GSM in the future, whereas high data rate multimedia services and mobile office applications will be handled by UMTS. UMTS mainly affects the air interface, where a broadband transmission method achieves high transmission speeds. This requires considerable changes to the network architecture. Thus, especially at the beginning, a close cooperation with the existing GSM network structure is necessary to guarantee the services are supplied area-wide.